All right, number 20. Looks innocent enough. Turns out it's not. Let's see, the first thing to notice here is that we have vertical asymptotes going on here. When the bottom equals 0 but the top does not equal 0 of a rational expression like this, you get what's called a vertical asymptote. And we can figure out where that happens by setting the bottom equal to 0 and solving. So we figure out that there's vertical asymptotes when x equals plus or minus 4. So really, so in this problem we're asked to find everything. And by everything I mean where's it concave up, where's it concave down, increasing, decreasing, critical points, etc., etc. So it's important to note that we have these vertical asymptotes when x equals plus or minus 4. So specifically, the domain of this function isn't everywhere. Domain. This function is not defined when x equals 4 or negative 4, right? Because you can't divide by 0. So our domain is only from negative infinity up to negative 4, and then negative 4 to 4, and then 4 to infinity. So this right here will be important to keep in mind as we're manipulating this thing algebraically, and when we think of where is it increasing and decreasing, we're just talking about out of this domain, where is it increasing and decreasing. So anyways, now that we got that down, we can start it. The way we'll learn about this function is the same way we normally do. First, take the derivative. Unfortunately, even the derivative is a little bit ugly because we got a product rule going on here. Derivative of the top is 6. Leave the bottom alone. Subtract from that, leave the top alone. The derivative of the bottom is 2x. And that is all divided by x squared minus 16 squared. So using the quotient rule, we get this, which we can simplify. Distribute that 6 through. And then 6x times 2x is 12x squared. And we'll leave the bottom as x squared minus 16 squared. And if you combine like terms, negative 12x squared and positive 6x squared gives you negative 6x squared minus 96 over x squared minus 16 squared. So I think that's far enough to simplify the derivative where we can start to look into things. Let's see, maybe we'll look at decreasing. We know that a function is decreasing if its derivative is negative. So what we have to do is take this derivative and set it less than 0 and then solve for what x's make this true. Okay, so it's tempting to want to multiply both sides by x squared minus 16 squared, right? Clear out the denominator on this side, it'll just be 0 on this side. You have to be a little bit careful when you do that. Because of this squared on the outside, what's down here will never be negative. So we don't have to worry about this inequality having to switch the sign or anything because this will never be a negative sign. We'll never want to flip that. But you do have to be careful because this could be 0 and you don't want to multiply both sides of the equation by 0. Fortunately for us, the only time the bottom here is 0 is when x equals 4 and negative 4. And 4 and negative 4 are not in our domain. So none of the numbers in our domain will make the bottom here 0. So because of that, we can multiply both sides by x squared minus 16 squared and get negative 6x squared minus 96 is less than 0, which we can then go on to solve. Add 96 to both sides. Divide both sides by negative 6. Careful when you divide by a negative, you got to flip the sign around. 96 divided by negative 6 is negative 16. So it's decreasing if x squared is greater than negative 16. Anything squared is greater than negative 16, yeah. So this is always true. AL. But maybe you need this asterisk. You got to be careful because always is not negative infinity to infinity in this case. It's always, maybe this gets parentheses, in our domain. So really the answer is it's decreasing from negative infinity up to negative 4. And then again from negative 4 up to 4. And then again from 4 up to infinity. So you got to be a little bit careful there. And if we move on, let's learn about concavity. We got to take the second derivative. There's no great form to take the second derivative of. I think the easiest way to do it will be to look at this guy, x squared minus 16 squared. But we can factor out a negative 6 from the top. Didn't really leave myself room. Negative 6 times x squared plus 16. I think in this form it'll be a little bit easier to take the derivative because we got this constant out in front, this negative 6. So to find the second derivative, maybe I'll switch colors. It's going to get kind of messy. The second derivative is the derivative of this guy. Leave the negative 6 alone. Multiply by the rest of this stuff. Let's see, we got a quotient rule. Derivative of the top is 2x. Leave the bottom alone. Subtract from that. Leave the top alone. And multiply that by the derivative of the bottom. Careful, we got a chain rule going on here. Outside function is x squared. So we got x squared minus 16. But then you're not done. We've just taken care of that part. We still need the derivative of the inside, which is 2x. So close up all my parentheses here. And because we are using the quotient rule, that is all divided by x squared minus 16 squared squared. So up to the fourth. So this huge mess is our second derivative. We can simplify it a little bit. What should we do? Maybe we'll leave this negative 6 out here. And we got 2x times x squared minus 16 squared. Let's see, over here, let's leave the x squared minus 16 and put the rest of the stuff together. So we got a 2 and a 2x. So there's 4x there. And if we distribute it through this guy, 4x times x squared is 4x cubed. 4x times 16 is 64x. And that is all divided by x squared minus 16 to the fourth. Okay, the reason I left this x squared minus 16 by itself is because we got x squared minus 16s over here, here, and here. Maybe this is a good spot to leave the second derivative. We'll call this f double prime of x. And we'll start working on one of the problems. Maybe where is this, I don't know, concave up? Let's see, we know that a function is concave up if the second derivative is positive. So we want this whole thing to be positive. So let's see, I'll do 2 steps right off the bat. So you're picturing all this stuff is greater than 0, but I'm going to divide both sides by negative 6. So that's going to switch my sign around here. So instead of being greater than 0, it's going to be negatives or less than 0. So that's dividing both sides by negative 6. And then while I'm here, I'm going to multiply both sides by x squared minus 16 to the fourth power. What's important to note is that this is never negative and it's never 0 in our domain. So it's okay to multiply both sides of an inequality by this. We won't mess anything up. So what that leaves us with, so if I copy that all down, it brings us here. Yeah, so to recap, we divided both sides by negative 6. That switched the sign around. And then we multiplied both sides by the denominator here. which was legit because this is always positive in our domain. We're going to take advantage of that fact one more time. X squared minus 16 squared is always positive in our domain. So we'll divide both sides of the equation by that, which will take care of this x squared minus 16 squared. It'll take care of this one. Maybe it's worth writing this out. I'm running out of colors. But what we're really doing is dividing this here, dividing this here, and then dividing this here. So if you do that, in hopes of simplifying, over here we're left with just 2x. And then over here we got, you know what, instead of leaving this as 2x, I'm going to look into the future a little bit, and I'm going to leave this, I'm going to call it 2x times x squared minus 16 divided by x squared minus 16. So what I'm going to do here is get a common denominator of x squared minus 16. So I'm going to cancel out, let's get another color. I'm going to cancel out one of these with one of these and one of these with this whole guy. And the reason why is I want a common denominator in my next step. So if I do that on this side, this is what I have left. On the other side, I will have 4x cubed plus 64x. And I want to figure out when this is less than 0. I think if we go one more step, we'll be able to figure out where it's less than 0. Let's distribute this through and collect like terms. 2x times x squared is 2x cubed. So we got 2x cubed minus 4x cubed, which nets out to negative 2x cubed. Then 2x times negative 16 is negative 32x. So negative 32x minus 64x is minus 96x. And that gets divided by x squared minus 16. Whew. So finally, we want to figure out when this thing is less than 0. And actually, let's simplify this one more time, make the top a little bit easier to look at. Pull out a negative 2x, and then what we're left with is x squared plus 48. And now I think we're at a point where we can figure out when this is true. So this is true. There's two different ways this can be true. It can be true if we're in this positive number divided by negative number case, or if we're in a negative number divided by a positive number case. Let's see. So let's look at the top first. What x's will make the top positive? Well, this thing right here is always positive. This thing right here will be positive if x is less than 0. Yeah, if x is a negative number, negative times negative makes this a positive. Similarly, the top here will be negative. This is always positive, so the top will be negative if x is greater than 0. What about the bottom? The bottom is negative. Let's see, when is this negative? Well, we need x squared to be less than 16 in order for this to be negative. So this happens, it's negative if x is between negative 4 and positive 4. That is, if negative 4 is less than x is less than 4. And it's positive if x is less than negative 4 or x is greater than positive 4. And I think if we figure out when this and this happens, we'll have half of our answer, and then when this and this happens, we'll have the other half. So this is saying when x is between negative 4 and 4. This is saying when x is less than 0. So for both of those things to happen, we need x to be between negative 4 and 0. And for this, we need x to be positive, and we need either x to be less than negative 4. Well, that can't happen, right? You can't be less than negative 4 and be positive. Or x be bigger than 4. So we need x to be bigger than 0 and x to be bigger than 4. Another way of saying that is everything from 4 to infinity. So finally, our final answer, taking these two guys together, we get that our final answer is we are decreasing. No, concave up. We're concave up on this interval here. And maybe looking at this, you can figure out where the critical points would have to be. Keep in mind that we got vertical asymptotes going on, and figure out based on this where it's concave down. And hopefully that'll save you some time on this extremely long problem. Hope that helps.